Assalamu alaikum. I am Ansari Safiya from Department of Physics, J.A.T Arts, Science and Commerce College for Women Malegaon. Today we have to study linear simple harmonic motion. A common example of simple harmonic motion is spring mass system. Figure shows spring. A mass M is attached to one end of an elastic spring with other end tied to the rigid support as shown in figure. Mass M is set into oscillation on frictionless surface. When the spring is in unstretched condition, the mass is in its equilibrium position or in relaxed mode. If the mass is pulled through a small distance x and released, then the mass is set into oscillation. The oscillations are set up due to the elastic restoring force set by the spring directed towards the equilibrium position. This motion is called simple harmonic motion. As it occurs along a straight line, the motion is also called linear simple harmonic motion, which is defined as a body is set to perform linear simple harmonic motion if it is acted upon by a restoring force which is directly proportional to linear displacement from the mean position and is directed opposite to the displacement, that is towards the mean position. Now suppose that x be the displacement from mean position at an instant of time t, then from the definition of linear SHM we have restoring force is directly proportional to displacement, that is F is directly proportional to x, or F is equal to minus kx, where k is constant of proportionality called restoring force constant, which is defined as restoring force per unit linear displacement, and negative sign indicate that force and displacement both are oppositely directed. According to Newton's second law of motion, force is equal to mass into acceleration, that is F is equal to m into d square x by dt square, where d square x by dt square is acceleration. Hence m d square x by dt square is equal to minus kx. Rearranging this equation, we get m d square x by dt square plus kx is equal to 0. Now dividing this equation by m, we get d square x by dt square plus k by m into x is equal to 0. Now this equation involves derivative, therefore it is called a differential equation. Now suppose that omega square is equal to k by m. Therefore above equation becomes d square x by dt square plus omega square x is equal to 0. Now this equation is called the differential equation of motion of simple harmonic oscillator. This is second order linear and homogeneous differential equation in x. Linear because there is no product term of dependent variable and its derivative. Also the power of dependent variable and its derivative is 1. Homogeneous because each term contains dependent variable and its derivative. Now the solution of this equation is of the form x is equal to a sin omega t plus phi, where a is amplitude which represents maximum displacement of particle about mean position on either side, and omega is called angular frequency of the oscillation. Thank you.